So we're carrying on from where we left off. We're on episode 2 of our limits series in our maths module. This episode and the following episode are both going to be on a few examples, both of which are going to be taking limits to infinity, minus infinity, and 0. If you think you're okay with limits dealing with to infinity, minus infinity, and 0 from the last video, then go ahead and skip these next two ones. If you're not, then stay and have a look. So I've wrote down a few questions here, and we're going to begin to tackle some of these. We should get through question 1 and 2 in the first video, and then move on to question 3 with some more complicated functions in the second video. So we're going to start with 1a, and this is taking the limit of the function e to the x plus 2 to 0. So from what we took from the last video, we can put in e to the 0, which we know is going to be 1, plus 2, and we're going to get 3. Very straightforward. So for this limit, as x approaches 0, the function approaches 3. Next we're going to have a look at the second one, which is for the limit again as x approaches 0, but for 4 over x. So if we were to sub in on this one, x is 0, we end up with 4 over 0, which is something we can't actually equate. So what we have to consider is anything that's getting divided by 0 effectively takes it to infinity. Because as I said before, we never actually quite reach 0, so simply subbing in 0 doesn't work here. Also, what we need to consider is if we approach 0 from strictly the plus side, all of our values as we're coming up to 0 are going to be giving us a positive answer, taking us to positive infinity. But if we approach 0 from the negative side, it's all going to be giving us a negative answer, taking us to negative infinity. So as, for this one, as x goes to 0 from a strictly positive side, where we have a superscript plus, f of x goes to infinity, and where x goes to 0 strictly from the negative side, f of x goes to minus infinity. Now, if we go to our next question, again, this is for C, this is the same, but now the x and the 4 have been flipped over. And for this one, we don't need to consider which side we approach it from, because as we approach this, we are still getting closer to 0, because we are going towards a value, whereas for B, we were diverging away from 1. So we're still getting closer to the same value. So this one is simply 0 over 4, so we have 0 as that limit. So if we move down to the second set of questions, and these are limits to infinity. So our first limit is for x as it approaches infinity for 3x plus 4 minus x squared. So for this limit here, if we look at this, we can say, well, we have infinity going once in the plus direction, and we have infinity going exponentially in the negative direction. So even though it looks like you'll be going to infinity when we first look at it, we'll actually be going towards negative infinity, because the infinity is exponential there and increasing much faster than is negative. So that means for 2a, we are actually approaching, our f of x is actually approaching negative infinity. If we look at our second problem, we have a limit of x going to minus infinity, and we have our function as x cubed plus 2. So the cubed doesn't really matter here because we have no other x terms. So the rate at which it gets to infinity doesn't matter because our final value is always just going to be infinity. And the fact that it's cubed means it retains its minus sign. So the 2 compared to that is just ignored. and we can take this limit as our function of f of x is going to minus infinity. And for c and 2, we are looking at a limit to infinity for 56, doesn't really matter, just any number, 56 over x. So now what we're to consider with this is we've got a limit of 56 over infinity. And notice when we're doing something over for 0, we are considering sign, and for infinity when we don't have to consider which side we approach it from, because we only approach infinity from one side. And anything that's divided by infinity is such a small value, such an infinitely small value because infinity is infinite, that this then can be considered 0. So as x goes to infinity, our function of f of x goes to 0.